Hello everyone, a very good morning and welcome to my course Physics 1. This course is generally made for undergraduate level BTech degree students. Myself, Gopal Chakraborty, Assistant Professor, Department of Physics, Greater Kolkata College of Engineering and Management, Baruipu. You can personally meet me at college premises, ground floor physics lab. You can also send me a mail regarding your doubts and queries to my given mail address, that is godphysics6@gmail.com or gopal.chakraborty_gkcem@jisgroup.org. I have a YouTube channel, students. You can subscribe my YouTube channel for lots of videos that I have uploaded for the subject Physics 1. I have followed that McCourt University curriculum for first year degree BTech degree students. So you can go through that videos, and if you feel any doubt, feel free to contact me at my given mail address. So the students, for this subject I am your subject teacher. Now, the corresponding course pages are www.maccoutexam.net and www.maccoutwb.ac.in. So students, the syllabus is already uploaded in the university website. So if you want, you can download the syllabus from the given mail address. So the title of this course is Physics 1, and the corresponding subject code is BSPH 101. It is under the category of Basic Science course. It has a credit 4 and 3 lecture per week and 1 tutorial per week. This course is generally made for undergraduate level BTech degree students of first year. So the students of computer science, civil, mechanical, these departmental students will going to study this course in the odd semester, and alternatively electrical and electronics, these departmental students will going to study this course in the even semester. So for that case, only the subject code will change, that will be BSPH 201, but the syllabus is almost same for electrical and electronics departmental students. Now, in today's class, the topics that I will going to be discuss are applications and different numerical problems from chapter Quantum Mechanics. This is under also the module 4, that is Quantum Mechanics. So a prerequisite for these topics are elementary idea of quantum mechanics and fundamental idea of mathematical calculation and also quantum mechanical operator. The course objectives are idea about application of quantum mechanics to solve different types of numerical problems to find the normalization factor, quantum mechanical operator, expectation value, degeneracy, probability, energy eigenvalue for a given wave function, and etc. So after completion of this course, the students will able to learn and calculate the normalization factor, quantum mechanical operator, expectation value, degeneracy, probability, energy eigenvalue for a given wave function. So these are considered to be as possible course outcome. So the students, today I am going to be discuss regarding lots of application and numerical problem on that chapter quantum mechanics. But I have already uploaded 7 videos on this chapter quantum mechanics. So those who have missed those class, please go through that class, because this is basically a last class on that quantum mechanics, where I am going to solve lots of numerical or application problems. So without knowing the basic idea of quantum mechanics or the details calculation related to quantum mechanics, it will be very difficult for you to understand how to solve this numerical or that application. So it will be better, please go through that class or lectures that I have uploaded, so it will be very helpful for you. So where in last class I want to remind you that the things that I have discussed that about what is quantum mechanics, why we have started this quantum mechanics, and I have also discussed regarding a wave function which actually plays important roles in quantum mechanics. So in what is wave function? So it is one of the postulate of quantum mechanics that for a physical system consisting of a particle, there is an associated wave function. So this wave function determines everything that can be known about the system. The wave function is assumed here to be a single valued function for position and time, since that is sufficient to guarantee an unambiguous value of probability of finding the particle at a particular position at time. The wave function may be a complex function, since it is its product with its complex conjugate, which specifies the real physical probability of finding the particle in a particular state. So in wave function, that is basically denoted by psi, it is a function of position and time, and the probability that also plays an important role, because probability will give you the chance of getting the particle for a particular boundary region. It may have maximum value or may have minimum value. Okay, so for probability value is equals to 1, its maximum, that means chance of getting the particle is maximum, and if the probability is 0, that means probability is minimum, that means chance of getting the particle is minimum. So this probability, by using that probability or finding the value of probability, you can define the particle. Okay, so also we have discussed the details about the characteristics of this wave function, where it actually can be called a single valued, continuous, square integrable, and finite function. Okay, so its space derivatives are also continuous, finite. So these are the characteristics of wave function that I have discussed. I have also discussed what are the physical significance of that wave function, and also the basic postulate of quantum mechanics. So that's things you need to know, because in quantum mechanics each and every dynamical variable is behave like a operator. So operator means it's basically a function. So when you operate this operator over some quantity, it will change the value of that quantity to another quantity and give you a new value. So here the use of quantum mechanical operators are there, and I will show you how it you can use this quantum mechanical operator to find out the value of expectation value or some commutator and so on. So and another important thing is that you need to know what is normalization factor, because normalization condition means for that particular condition you will get the probability maximum. So that means integration minus infinity to infinity, or the boundary may be different as given in the numerical problem. So it is the integration, psi is a wave function, so psi star of psi d tau, that's value is equals to 1. So this is the condition for a normalization of some wave function, so which makes a wave function normalized by multiplying by some constant term, constant value, which is a term as normalization factor. So these things are very important, because using these you can also find out the value of the normalization factor or the normalized wave function also. So I will show you lots of example on these topics. Okay, so I have also discussed in my last class regarding the one-dimensional and three-dimensional time independent and time dependent Schrodinger equation and corresponding solution, probability, eigenvalue, eigenfunction, energy eigenvalue. Okay, so please go through that video once again. Today I will show you how you will solve the numerical or application related to this chapter, quantum mechanics. Now the first problem: why cannot we represent matter waves associated with a free particle by a wave function that is given psi, function of x and t, position and time, that's equals to a sine omega t minus kx. So how we will solve this problem? The wave psi x t function is equals to a sine omega t minus kx, represent a wave of wavelength lambda equals to 2 pi by k, and frequency nu, that is equals to omega by 2 pi, associated with a particle traveling along the positive x direction. If the same particle travels along the negative x direction, then the wave equation will be psi function of x and t, that's equals to a sine omega t plus kx. Now the resultant wave due to their superposition can be written as psi function of x and t, that's equals to a sine omega t minus kx plus a sine omega t plus kx. So if by joining these two you can write that is equals to twice a cos kx sine omega t. So the above equation shows that psi function of x and t, that's equals to 0 for time t equals to 0. As psi represented by equation 1 might also be a wave function according to principle, but as psi is equals to 0 at t equals to 0, the probability of finding the particle is 0 everywhere. So psi is equals to a sine omega t minus kx cannot represent a wave function. So it is very clear to you that you have to find out the probability as that's equals to 0 everywhere. So this equation, this psi wave function cannot be represent a particular wave function. Second one, out of the given wave function psi equals to e to the power x, psi equals to e to the power minus x, which one is an acceptable quantum mechanical wave function? So for the wave function psi equals to e to the power x, we see that if you put psi equals to x tends to infinity, you see that psi tends to infinity. So for acceptable wave function, psi of x must have a finite value. So for x tends to infinity, so psi that's equals to e to the power x cannot be an acceptable wave function. Next one, for the wave function psi equals to e to the power minus x. You see, you just put x equals to plus minus infinity, that will give you psi tends to 0. So as it is psi has a finite value, so you can say that psi equals to e to the power minus x is an acceptable wave function. Next problem. Show that the particle cannot exist in an one-dimensional box if its energy is 0. So the wave function for a particle enclosed in one-dimensional potential box having width small a, that can be represented by the solution of Schrödinger one-dimensional time-independent equation, that is psi equals to under root 2 by a sine n pi x by a. Now from there, the energy eigenvalue that can be written as E n suffix n, that's equals to n square pi square h cut square by twice m square. Now if E suffix 0 is equals to 0 for n equals to 0, so pi naught equals to 0, you know h cut naught equals to 0, as well as m and a value is not equals to 0. So psi 0, that value will be equals to under root 2 by a sine 0 into pi x by a. Ultimately sine 0 is 0, so psi of 0 will give you 0. Hence the particle cannot be present in this box if E is equals to 0. Next problem. The normalize the wave function. A wave function is given here and you are asked to find out the normalized wave function. So what are the given one? That is psi, that's equals to a sine pi x by a, for x is 0 within 0 to a, and psi is equals to 0 outside. Now the condition of normalization is the probability will be maximum, so integration 0 to a psi star psi dx, that value is equals to 1. So now as it is a not normalized wave function, so you just multiply the wave function with a constant, unknown constant, that is a. So after multiply by the a, you will get a normalized wave function. So here a is already there, so you just substitute the value, you will get a star a integration 0 to a sine square pi x by a dx is equals to 1. So a square integration 0 to a half of 1 minus cos 2 pi x by a dx, that value is equals to 1. So a square by 2 integration 0 to a dx minus integration 0 to a cos 2 pi x by a dx, that's equals to 1. So if you complete the integration, you will get x from lower limit 0 to upper limit a minus a by 2 pi sine 2 pi x by a, lower limit 0 upper limit a, so that value is equals to 2 by a square. So small a equals to 2 by capital A square, where capital A value is equals to under root 2 by a. So this is a normalization factor. Now if you substitute the value of a in the above equation, that will give you the normalized wave function. So the normalized wave function will be psi function of x, that is equals to under root 2 by a sine pi x by a. So this is your normalized wave function. another example, that is normalize the wave function given psi that's equals to a e to the power minus a square x square by 2 e to the power I k x. So again, by putting the normalization condition, that means the probability will be maximum. So integration minus infinity to infinity plus infinity, we choose that limit because no boundary value is given there, mentioned there in the numerical. So we just put the lower limit minus infinity and upper limit plus infinity to cover all the area. So mod of psi square dx, that value is equals to 1. So mod of a square, integration minus infinity to infinity e to the power minus a square x square by 2 whole square e to the power I k x into e to the power minus I k x dx equals to 1. So the second part, e to the power I k x into e to the power minus I k x, that becomes e to the power 0, that means 1. So ultimately we get mod of a square, limit minus infinity to infinity e to the power minus a square x square dx, that value is equals to 1. So capital A square under root pi by a, that's equals to 1. So the integration minus infinity to plus infinity e to the power minus a square x square dx, that value is equals to under root pi by a. So substituting that value, ultimately we get a value that's equals to a by small a by under root pi whole to the power half. So the normalized wave function is psi function of x, that is equals to a by under root pi whole to the power half e to the power minus a square x square by 2 e to the power I k x. Next problem, show the wave function given by psi equals to under root 2 by L sin n pi x by L are orthonormal. Orthonormal means it simultaneously satisfies the condition of normalization and orthogonal condition. So simultaneously your the probability will be maximum and minimum for n equals to m. Let psi n and psi m be the wave function corresponding to a particle having energies En and Em respectively, where n and m being the integer value. Now psi n, that's equals to under root 2 by L sin n pi x by L, and psi m, that's equals to under root 2 by L sin m pi x by L. So integration limiting from 0 to capital L psi star m psi n dx, that's equals to 2 by L integration 0 to L sin n pi x by capital L sin m pi x by capital L dx, that's equals to 0 if n not equals to m, and 0 to capital L psi m star psi n dx equals to 1 for n equals to m. Hence the function psi n function of x and psi m function of x are orthonormal. Now another very important problem, the wave function for a particle is given by psi function of x, that's equals to c e to the power minus alpha square x square, where x value is from minus infinity to plus infinity and c and alpha are the constant. So calculate the probability of finding the particle in the region 0 to infinity. So here the probability of finding the particle from 0 to infinity is capital P equals to integration 0 to infinity psi star psi dx, that's equals to 0 to infinity c star c e to the power minus 2 alpha square x square dx. So that's equals to c square integration 0 to infinity e to the power minus 2 alpha square x square dx. So if you solve the integration, that will give you value under root pi by 2 alpha. So if you substitute that value, you will get the probability P is equals to c square under root pi by 2 alpha. Again, to find the value of c, we use the normalization condition. So integration minus infinity to plus infinity psi star dx, that's equals to integration minus infinity to infinity plus infinity, c square e to the power minus 2 alpha square x square dx, that value equals to 1. So from there we get the c square value is equals to under root pi by alpha. So ultimately we get the probability value is equals to c square under root pi by 2 alpha. If you substitute the value of c, you will get probability will be half. So the probability of finding the particle in the region minus infinity to plus infinity is 50%. Now the next problem is on basically on operator. Prove that if alpha cap beta cap within square bracket that's equals to 1, then within square bracket alpha cap 2 beta cap square is equals to 2 beta. So you have to prove that. Okay, so as you know by the property commutator property, so first one alpha cap beta cap, that value equals to 1, that means alpha cap beta cap minus beta cap alpha cap equals to 1. So beta cap alpha beta cap minus beta cap square alpha cap is equals to beta, and alpha beta square minus beta alpha cap beta cap, that's equals to beta. So adding equation 1 and equation 2, we can write alpha cap beta cap square minus beta cap square my alpha cap, that's equals to 2 beta. So this actually you can write within a square bracket alpha cap 2 beta cap square, that's equals to 2 beta. So it is proved. Next one, you have to prove that within square bracket L square L z cap, that's equals to 0. So L cap square L z cap within square bracket, that can be written as within square bracket Lx square plus Ly square plus Lz square comma Lz cap. So by substituting in the formula, you get Lx square cap Lz cap minus Lz cap Lx square cap square plus Ly square cap Lz cap minus Lz cap Ly square cap plus Lz square cap Lz cap minus Lz cap Lz square cap. So ultimately we will get that's equals to Lx cap Lx cap Lz cap minus Lz cap Lx cap Lx cap plus Ly cap Ly cap Lz cap minus Lz cap Ly cap Ly cap. So ultimately we get that value is equals to 0. Now the next problem on to find out the expectation value of linear momentum for a given wave function. So the given wave function is psi, that value is equals to under root 2 by L sin pi x by L for x value is within 0 to capital L and 0 elsewhere where x is greater than 1. So you have to prove that expectation value of linear momentum for this wave function is 0. So to find out the expectation value of linear momentum operator, so px within that bracket is equals to integration minus infinity to plus infinity psi star px cap psi dx whole divided by integration minus infinity to plus infinity psi star psi dx. So that's equals to integration minus infinity to plus infinity psi star within bracket minus I h cut del del x psi dx whole divided by integration minus infinity to infinity psi star psi dx. So that's equals to half integration minus L to L capital L 2 by L sin pi x by L minus I h cut pi by L cos of pi x by L dx. So that's value is equals to pi h cut by 2il square integration minus L to plus L 2 sin pi x by L cos pi x by L dx. So ultimately from there you will get pi h cut by 2il square integration minus L to L sin 2 pi x by L dx. So after solving that integration you will get 0. So ultimately you will get the expectation value of linear momentum, that's equals to 0. So this is similar problem. Find out the expectation value of px square for the wave function. So it's a square of the linear momentum operator. So simply I have followed the last problem that I have derived in the earlier, where you find out the expectation value for the linear momentum operator. So here you just substitute in place of the linear momentum operator, that is minus I h cut del Lx, you just replace by the square of this, and if you substitute this, you will follow the same rule, same procedure, you will get the expectation value of that px square will be pi h cut square by a square. So I have already derived this. You can see the how I have derived this. Next problem, find out the values of momentum and energy for the ground state of an electron confined in a cubical blocks of side 1 angstrom. So for the ground state, nx equals to ny equals to nz, that value is 1. So the momentum P111, that's equals to pi h cut by a under root 3. So pi h cut by 2 pi a under root 3. So that's equals to h by 2 pi under root 3. So if you substitute the value of h, Planck constant, and the value of a, so that will give you 5.74 into 10 to the power minus 24 kg meter per second. Next, the energy will be E in 111 state, that is pi square h cut square by twice m a square, so into 3. So that's equals to h square by 8m a cube under root 3. So if you again substitute the value of h and a and also m, mass of the electron, so that will give you the value 181 into 10 to the power minus 19 joule. So ultimately it is 113 electron volt. Now for the first excited state, one of the quantum number is 2, so the momentum will be P211 or P121 or P112, that value will be equals to pi h cut by a under root 6. So now again if you substitute the value h by 2 pi under root 6, so that will give you 8.13 into 10 to the power minus 24 kg meter per second. Similarly, you can find the energy, that is E2211 state or E121 or E112, that equals to pi square h cut square by twice m square into 6. So substituting that value will give you the energy eigenvalue will be equals to 226 electron volt. So these are the book that you may refer for solving lots of numerical and application on this chapter, quantum mechanics. So the evaluation process is same. You have to appear for a end semester 70 marks exam and internal exam for 30 marks. So with this video I have completed the chapter quantum mechanics. Hope all of you have enjoyed and understand. So thank you.